One question that we often ask about machine learning techniques and about any techniques in general is when to use such technique when we have alternatives. Well, to be able to answer this question, it is necessary to know the pros and cons of this technique, and hopefully we would easily make our decision about whether to use it or not. Therefore, in this video I will be talking about the advantages of decision trees. And based on that, we can probably know why to choose decision trees, because we would need to know also about the inconveniences. Therefore, I will talk about that in a separate video. Well, the first advantage of decision trees is that they are versatile, so it's versatility. And versatility means that this technique can be used for both regression and classification problems as well. Also, it can be used for numerical features and categorical feature as well. Numerical feature is something like a weight or a length or age, and categorical feature is something that is like a category. For example, the brand of a car or the breed of a dog. So these are called categorical features. And the nice thing about decision trees is that you can create trees or models that contain both numerical and categorical feature in the same time, in the same decision tree. And this is a very nice property to have. Another advantage is that decision trees require very little data pre-processing, requires very little data preparation or pre-processing. So it does not require things like feature scaling or centering, etc. But they do require, however, some data pre-processing. For example, before training your tree, you need to make sure that the classes are balanced. I will talk about that later in the video of the disadvantages of decision trees, because when the classes are not balanced, then you have a problem of bias. I will talk about that in another video. And another advantage is that, which is a very nice property actually, is that decision trees have the property of automatic feature selection. So what is the meaning of this? This means that the feature, or rather the decision tree, use the most relevant feature. And the reason why this is the case is because the training algorithm, such as the CART algorithm, looks for the best pair feature threshold that would separate the data in the best way, that would yield the best separation, the highest separation quality. And also there are some other things that contribute to that. For example, when we have a tree like this one, then it is possible to, before growing the tree, we need to verify a given condition. For example, if the information gain or the impurity is not decreased after splitting this node, for example, then we do not split this node into two leaves. Okay, so what we do is that we evaluate the impurity of this node before splitting, and then again we evaluate the impurity of this node after splitting, and then if there is no enhancement in the impurity, that is, there is no decrease in the impurity, we don't split that into two leaves. And this is also why this property of automatic feature selection happens. So again, another advantage is that decision trees are very fast when compared with other classifiers, and in particular, its speed linearly dependent upon the depth of the decision tree. Remember that the depth is the number of nodes, or the maximum number of nodes along a given path. So this is the depth. And the speed depends upon that depth in a linear way. Also, decision trees are called white box models. Unlike some other machine learning techniques, for example, the convolutional neural networks are called black box models because they are not interpretable. This means that we cannot understand why a given decision was made, whereas for the case of decision trees, it is completely interpretable, and we can understand why we took a given decision. So in some libraries, for example, such as the scikit-learn, even gives you the option to visualize your tree and understand why you did take a given decision. And this is very important in some cases. For example, let's say that you are dealing with a client who want to understand why you took a given decision for him. So in that case, you can show the decision tree to him and tell him what, well, we took a given decision because, you know, these are all the steps that are involved in our decision tree, and this is why we did take a given decision. And the last advantage of decision trees would be handling missing data. So what is the meaning of this? For example, what does missing data mean in the first place? Well, say that I have a model that involves 3 features, F1, F2, and F3, and I gathered, of course, a data set about these 3 features. So let's say that for all features, I have a given value, but for this particular sample here, I don't have the value for feature 2. So this is called a missing data. And to deal with that, and of course here I'm talking about the training data. I'm not talking about the test data. I'm talking about the training data. And in general, one way that we can, one way around that is to completely ignore this sample. Otherwise, we can do better. We can conclude this value based on these values. So, for example, I can say that this value is the most common value inside this column here. And another way to conclude this value is to take the mean, the average or the median of all of these values of feature 2, of course, because I have a missing data for the feature 2. So I can take the median of all the values that I have here and say, well, the median is the value that is missing. And of course, the median should be applied if this feature is numerical. If it is categorical, then we don't do that. We rather just take the most common state of this feature. And of course, there are some other methods. For example, what I can do is to look for the feature that has the highest correlation with this feature that has the missing data. For example, let's say that feature 2 and feature 3 have the highest correlation. So in that case, I can take 2 actions. The first action is to say, well, this missing data is the same as this value, because these 2 features are highly correlated. Otherwise, a better approach is to build a linear model. For example, I can say, well, this is feature 1 and this is feature 3 because they have, this is feature 2 and this is feature 3 because they are the two features that have the highest correlation. And then I can take all of these data here and plot them and then work out a regression model, for example, a linear regression model, and then say that this missing value is here. What I can do is to conclude it from this model and say, well, this value here is the same as this value. So these are some ways that we can use to handle missing data.